Okay, so hello everyone. My name is Sharmaigne Mabano, and with me is my partner Tyrael Lada. And today we'll be talking to you about a Pythonista's guide to competitive programming when he gets the slides working anytime now. A bit of a background about who we are. So we are fourth year computer science students at the University of the Philippines, Mindanao. We're both working as a software engineer and as a junior DevOps, say junior DevOps engineer. But our love for competitive programming actually started way before that. Me, way back in high school, and L, I sort of roped him into it like first year of college, and now I would say he's a lot better than me at it, as you can see in those rankings, pero medyo blurry siya. So this is L, and then this is me, and then these are like other people sa UP Min. This is me winning the IT Week 2024 hackathon last year, and then I was gonna show you our Codewars rankings, but it wasn't letting me sign in, so you'll just have to imagine it. His ranking there is really high. Anyway, so we don't have much to show in terms of like actual big competitions, and the reason for it is because competitive programming isn't that big here in the Philippines, in the sense that there are a lot of events that you can go to. A lot of it is really online. You'll have to find sort of the competitions yourself. And I hope this is something that this talk is something that maybe changes that a little bit for the communities here in Davao. And we want to show you just how fun it is and how useful it is. So next slide. Sorry. Okay, so this is L's coined term. You might have heard of documentation-driven development, test-driven development, all these things, but we personally like to go by dopamine-driven development, and he's gonna tell you more about
it. Hello, so... Oh, it's not on. Sorry. Hello, so I'm sorry for this flickering thing. I don't know why that's happening. I think it's the difference of aspect ratio. But... So yeah, long story short, we both have ADHD, and that plays a lot into what we want to do and why we do things. And yeah, as the title or like this part of this segment is called dopamine-driven development, we really value high, fast positive feedback loops, and working on problems like this, it allows you to get to the exciting part of development, solving the critical problems without having to go through like setting up a project, right? You're gonna be able to constantly test yourself against problems that you can solve, and then while you're doing that, even though you're not actually ending up with side projects that you can present to people, you can feel yourselves getting better. You can feel yourselves enjoying programming, and I feel like that is an underappreciated aspect of programming. It's like that you want to program. So yeah, I feel like that compounded with everything else has led to us having this shared hobby of programming. Yeah. So you want to talk about this one?
Sure. Another thing is the competitive nature of it. So it's competitive programming, right? So when you're doing Leetcode, usually you're doing it to get a job, but we do it for the fun of it. And the reason is because you get to compare yourselves with other people, which is always fun. So in these competitions, you have leaderboards and contests. And I think a really fun thing about it is it's not just telling you, oh, this is the amount of time that other people have taken. You can also see their code. And what happens there is you not only get to learn by solving the problem, you get to learn by looking at how other people have solved the problems. So a lot of new tricks in Python and whatever languages I'm learning. So if I'm learning a new language, I usually solve a few problems in Codewars in that language because I get to see how other people do it, and I see they usually vote na, oh, this one is a really optimized one, or this one is very, very clever. And I get to see new sides of, oh, I could have done it like this. So that's the optimization part. And it drives you to do better because you see that you see the things that are possible, that it's like your solution, while it works, it's not the best one, and you can always optimize it. And this one is from L, so can you expound about this?
Since you're comparing yourself to others, sometimes you can feel much better about yourself when you see code. Especially if like you see someone do a linear search on a sorted array, you feel much better about yourself because you know how to do binary search, right? So that feels nice.
Yeah. So these are some platforms. So as I said, there are competitions, but they are very far and few in between, especially in person ones. So in Davao, I think ADU IT Week is the only one that's always present. Someone asked me about this a while ago, actually. In the Philippines, I think, is it University of the Philippines, Manila? They do Hack Olympics every year also. No, Algo Olympics every year also. But the universities here in the Philippines don't really join them. These ones, they're not like for a specific age group or anything. You can join them anytime. I would my favorite ones from here are Codeforces, Codewars, and Advent of Code for different reasons. So Codeforces, it actually has real-time competitions. So every week there's like a weekly competition that you can go to for like 2 hours. Code Wars is fun for me just because that's the one I use the most. And Advent of Code is something that we share every single December. So every single December, new problems show up. And yeah, it's a really fun time. I wish you guys could join us this December. Next. So now we're gonna move on to problem types. Don't worry, we'll get to the Python specific parts later. But for now, a little bit of the problems that you might encounter in competitive programming. So on the right, you have a photo of the Leetcode roadmap, which is basically a roadmap someone made with like different types of problems that you can find in Leetcode. I'm not going to go over all of them, but basically what you have to understand is that once you learn the patterns, you're going to have a much easier time because you're going to know, oh, this is a greedy algorithm, which means this is a greedy algorithm problem, which means that I can solve it this way. Or dynamic programming means that you can break down something over and over again recursively. There are also problems that require you to understand how to manipulate bits. So basically, having different types of problems allows you to sort of learn more about the language, learn more about programming. For example, someone asked me in one of my internships, like, what map was because they didn't use it before, and that was shocking to me because map is sort of one of the first things you use in competitive programming. So even though we do competitive programming for fun, I can honestly say that it's been a big part of how we learn things over the years, and it's kind of a confidence booster knowing that we're not just coding from tutorials or anything like that, that we're actually trying to solve problems and using our brains. So yeah, next. So we're gonna get to a question that you might have, which is why the hell would we use Python? Like, wait, no, not that. So why the hell would we use Python? Like, raise of hands if you think Python is slow. Oh, no one. Oh, some people think Python is slow. So, someone asked this in PyCon Taiwan like a month ago, and everybody raised their hands because yeah, like Python has a reputation of being slow. So when you're thinking about competitive programming, where you need optimization in both memory and speed, you'll think, why the hell would we use Python when there are languages such as C or Rust? And that's a valid question. But someone told me, okay, next slide. But when we looked at how competitive programming is actually scored, you'll see that each problem has a corresponding score based on its difficulty. And then based on the number of problems that you solve and their corresponding score, that's how you rank people. So a problem is considered solved when it passes all the tests, it passes the threshold of the maximum amount of time, which is usually based on your time complexity, and also your memory complexity. Now, if you're looking at just the time and memory complexity, you'll think, yeah, C++ is the best. But you also have to consider that you're trying to solve as many problems as you can. Python is slow when it comes to execution, but Python is by far one of the fastest when it comes to ideation and actually coding, right? Because it's a very, very simple language and you have so many tools at your disposal already, as opposed to when you're using C or C++, where like the library might not be as big, might not have as many specific things, where you might have to implement a lot of the things on your own, and that's going to eat up into your time. Your time limit is very, very important, and that's usually usually what matters the most is your algorithm, not your programming language. So that's why I think the ranking in terms of what's most used is C++ in the high levels. It's C++ and then Python. But if you're just starting out into competitive programming, I highly, highly recommend that you start with Python. So now this brings us to data structures and then later on Python specific tips, which I will be discussing.
Okay, so these are names that you might have already encountered if you study computer science or just have been programming for a bit. So the reason these guys are here is because a lot of problems that you'll encounter in competitive programming is literally just solved by implementing one of these. So hash maps or dictionaries, I would assume that you would already know how to use this, since this is part of Python immediately. And again, this is one of the advantages of Python, is that a lot of the things you need are already in the language. If you were to be using C, you're not going to have hash maps. You're going to have to implement your own hash functions. You're going to implement resizing of dictionaries and maybe collision handling and all. But you're already going to have that in Python. So you're not even going to have to worry about implementing a hash map. You're just going to worry about how to use a hash map. And counters are in collections.counter. They are a type of hash map wherein you just give it an iterable of different items, and then it will give you a dictionary in return that counts how many, like the frequency of each item. So if you had an array of like AAB, it would give you a dictionary of A2 and then B1, and that's really helpful for a lot of problems. The next is queues and stacks. So stacks, you don't really need a library for that, because you can just use append and pop on lists. Those are already optimized to be pretty much as a stack implementation. But if you do need a queue, wherein you're going to be popping from the start, you're going to be pushing either from the start or the end, and then doing another operation at the end. So like if you're going to be pushing at the start and then popping at the end, or popping at the start and pushing at the end, you're going to need a queue for that. It's going to be in collections that double-ended queue, or as I like to call it, deque. So I'm kidding, it's DQ. And then next is a heap, and it's going to be in heap queue. Heaps, they are data structures that are really good for finding minimums and maximums. That's how you have mean heaps and max heap. If you need the lowest three values of a list, you're going to be using heaps. So heap queues, actually, they don't come with their own objects. They're just going to be manipulating lists as well. So you're just going to be passing a list, and then you're going to say .heapify, and then you're going to have a heap for that. The next is linked lists and trees. Those are pretty much the same. Not really the same. Yeah. Like if you have a linked list and then you tilt it a bit to the side, you're going to have a tree. So yeah, that's true. So the reason why we're talking about trees here is that, oh my God, so many algorithms that you're going to see are going to deal with recursive structures. You're going to see that a lot of the things that you're going to encounter even in work are going to be some variant of trees. If you're going to be working in game development and you want to check collisions, guess what? You're going to need a quad tree. That's sectioning sectioning regions in quadrants, and that's going to be represented as a tree. If you have some model in your backend that has some self-referential foreign keys, guess what? That's already another tree. Even so, that's also a linked list if it's just linear. So case in point, you're going to have a lot of trees when you're going to be working in the industry. So yeah, trees all the way down. Like if you're parsing, you're going to encounter syntax trees, hotel tree vago or something. So next is lastly, additional tips and tricks. These are specific to Python. So these are things that I learned when we have been working on it. So data classes for clean struct-like objects. This is a last year discovery for me. If you've been working in other languages like I have, you're gonna learn to miss having structs, which is you have the struct word, the name, and then just declaring attributes for it. But in Python, you're gonna have to use def init, right? Init and then self dot, and then you assign the values there. But if you wanted to do it really fast, you could use a data class. How that would look like is like this way. Oh, I'm sorry.
How much time?
So if I open
5 minutes.
if I open Py and then I just import data, sorry. Can you hold the mic? Sorry. From data classes,
By 5
import,
minutes, huh?
yeah, data class, and you just add a decorator to a class, and then class name, and then you say first, then you give it a type here, and then last string, and that already works. You'll already have an object with first and last when they're gonna be strings. So if you declare it, you're gonna have to pass first and last. So that's really clean. Next is understanding big O. Sharmaigne mentioned this earlier about space and time complexities. Because really in competitions, they're not going to be actually timing your code. They're not going to be exactly timing your code. They're going to have some leniency on the language you use so that it's actually going to be measuring the big O. So it's gonna your code is gonna be if it's n squared, it's gonna be can I swear? I'm not gonna swear. It's gonna be bad. It's gonna be bad on it's gonna be bad if it's n squared. It doesn't matter what language you're gonna be using. So that's a really good important thing that you need to focus on. And then last is iteration constructs have different performance costs. You probably don't know this, but if you had while loops, a while loop and a for loop that iterated for the same number of times, for loops are going to be faster because for loops don't have to check in Python for loops don't have to check Python conditions. While loops have to check the conditions in Python. For loops are optimized in C. Next is if you wanted to create a list, you could either do a list comprehension or like having a for loop with an append, and then maybe like the map na function. But since list comprehensions can be done in one line, it's actually optimized by Python. If you can see it in the bytecode. Okay, I don't have time for demo. I'm sorry. You can just approach me later. But it's actually optimized in the bytecode. It has its own instruction for list comprehensions. But if you were to do it in a for loop and then appending to some list, that would be it won't have its own it won't have an optimization. That's why it's gonna be slow. And then for map, why is map faster than list comprehensions? It's only partially true. It's only going to be faster if your functions are already named outside of the map. And it's going to be faster because it's a generator. And I'm sorry, I don't have any other explanation on that. Generators are really fast. You should be using them. Range is a generator. Maps, filters, they produce generators. And then map, moreover on map, why I really like map, is if you provide multiple iterables for map, they actually pass the elements of your iterators at the same time to the lambda. So you can be doing zip operations on just one function call. So that's really cool. Nested loops are Cartesian products. This is a really far pull in discrete mathematics. So Cartesian products, these are if you have two sets like 1, 2, 3, and then you Cartesian product it with
ABC.
ABC. You would get an iterable of like 1, 2, 3, 1A, 1B, 1C. It would like match it with everything. That sounds like a nested for loop, right? Because it is. So if I open this, oh my god, I really want to demo this one. I'm sorry. From iter tools import product. So this is a Cartesian product. So if I did a product of 1, 2, 3 with A, B, C, and then I forgot to list it. List. It's here that this looks like a nested for loop, right? And if you unpack these tuples, you would have your nested for loop in just one for loop. And that is going to be faster because again, one generator over two generators, that is less than, one is less than two. So learn to use iter tools. Iter tools is really good. So if you don't know what iter tools is, it's this module in Python. I don't know if it's visible. It has a lot of function. Oh my god, it's so bad.
Go lang.
Yeah, it has a lot of functions that deals with transforming transforming lists. So if you see here, you have accumulate, batch, chain, compress, blah, 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 blah. There's take while, zip longest. And here we have product permutations. If you wanted permutations, you just have it immediately. And there's also combinations and combinations for replacement. Those generate everything that you need. Again, this is crazy because this is already in the language. And I think that would be all, yeah. So
Oh,
sorry
yeah,
for
just
the
to add,
rush.
it's not a library that you're supposed to download pa. It's part of the standard live. So yeah, that's fun. Yeah, thank you. I think we don't have time. Yeah, we don't have time for Q&A, but you can just approach us later. And if you want to join us in our competitive programming journey, then you can just approach us and we'll talk to you. Thank you.
Thank you so much.